So when we see a problem like this, I do figure that you can probably look at it and start coming up with some strategies, because it's like problems that you've seen before, even if you've never done one just like it. Insofar as you know what the equation will look like, we're given the format of it up here, and you got a couple points that we know that it's going to pass through. And if this were a line, we could actually just start plugging in the points, and we could like make it a system of equations. We can actually do the same kind of thing even with an exponential. It's just going to look a little bit different by the time all's said and done. Because notice what happens when we start plugging in. Remember the y-coordinate, remember that's just f of x. So it's going to be, for the first one, I could write it as 6 equals c times a to the power of 1. Okay, so that's just going to be 6 equals ca. Because a to the 1, of course, is just a. Okay, let's see what we get with the other one. 2/9 equals ca to the negative 2. Okay, we got a negative exponent.
C over a squared.
Yep.
Oh, yeah, Eric.
We've recently been practicing those negative exponents. All right, so if I deal with that negative exponent, I can rewrite that as c over a squared. Well, we now have two equations with two variables. We can solve them. Now, how we solve them, there can be a little bit of variation in strategies that we might choose to use. Personally, I think the easiest way would be to use the substitution method. Let's solve one of these equations for a variable, like make it either c equals or a equals. And since they're both just plain old c's, you know, the other one's an a, the other one's an a squared, use the c. Solve at least one of the equations for c, and then substitute. The first question ends up being, which one would you be solving? Well, you could solve the one on the left here. You could turn that into c equals 6 over a. Or you could solve the second one by multiplying both sides by a squared. That would give you c equals 2a squared over 9. So which one would you like to do? Well, whichever one you can do most reliably. Like if you're looking at what this ended up being and you're like, oh, right. Well, then maybe that's not the one to solve for c equals for you. Maybe go with the other one. Although, you could actually solve them both for c like this if you wanted to and just set them equal to each other. But again, we have options. All right, so now that I've solved one, I'm going to go ahead and go with, let's say, this one. Because I really just want to deal with what happens along the way. All right, so I'm going to plug that c equals into the other equation. Let's make a little bit more space. And so if I do that, I would end up with 2/9 equals 6 over a squared. You know what to do with that?
Yep.
If the answer is yes, you know what to do with that and how to actually resolve the whole fraction within a fraction thing, then you're going to be okay. If the answer is no, well then, if that answer is no, break out your eraser and go with the other way. Because you could always substitute this c into the other equation. That would then look like 6 equals 2a squared over 9 times a. So as you go and do this, oftentimes you're trying to think ahead, and you're going to hopefully see some of these things ahead of time about what it's going to look like when we plug it in. But I'm wanting to remind you that it's okay to do it and then be like, oh wait, I chose the ugly route, I want to go a different route, and to change that. That's fine. So like from this form, it's actually a little bit easier to work with, because I'm going to go ahead and combine that a squared with the a, so that's going to give me 2a cubed over 9. And then we're just going to solve this equation for a. So go ahead and solve that for a, please. And I'm guessing most of you started by multiplying both sides by 9. Although a few of you will have written it as 6 over 1 and cross-multiplied. That also works. But I think of it as multiplying both sides by 9, in which case Actually, either way, you end up with 54 equals 2a cubed. Divide both sides by 2. And then get rid of the cube by taking the cube root of both sides. And so a equals 3. And now that we know that a equals 3, I can go figure out what c is. Because, of course, I have a couple different equations that I can work with here. In fact, I even am probably going to go back to the one that I solved for c just to make my life that much easier. And yes, you can use either one, of course, right? So then, I'm going to go ahead and I'm going to plug it into the one on the left because it looks a little bit simpler to me. So I'm going to do c equals 6 over a value, which is 3, therefore c equals 2. And so we have our final equation then, f of x equals ca, so 2 times our a value to the power of x. So there's our final answer. All right, so we approached this one the same way we approached the last one. I'm going to write 2 equations and see where it takes me. And a lot of times when doing this particular type of problem, that really is what you'll do, is you'll just plug this stuff in and see what types of equations you have to work with. Because that last one, it worked a particular way. This one will even have some similarities to it. But there's no guarantee that they'll always have, for instance, a fraction in them. But you can still follow the same basic process. All right, so for our first equation, I'm going to use that leftmost point. So that's going to be 3 equals ca to the power of negative 1. Simplify it however you can. So in this case, that becomes 3 equals c over a. All right, for the other one, it's going to be 4/3 equals ca to the power of 1. And of course, to the power of 1, that's just the same thing. So that's just going to be ca. And so we can solve either one for c. We're going to go ahead and use the left one here. So I'm going to multiply both sides by a, which means that c equals 3a. I'm then going to take that value of c and plug it in over here. So when I do that, I end up with 4/3 equals 3a times a, which of course then we simplify. 4/3 equals 3a squared. We can then solve from here. Divide both sides by 3. Now, be careful with that, or you might accidentally get on autopilot and forget what that gives you. That's actually going to give us 4/9, not 4. And so then we need to get the a by itself. That means getting rid of the squared here. So we take the square root of both sides. And we end up with a equals, and yes, you shouldn't need a calculator for this, square root of the top is 2, square root of the bottom is 3. And then we did take the square root of both sides, so yeah, plus or minus. But would it make sense for our equation to be some number times a negative 2/3 to the power of x?
No. Because it's a boat.
Extraneous. Okay, so we actually don't need the plus or minus.
Wait.
Yes, we need to think about it, but no, it's not actually going to be part of our answer here. We only need to worry about the positive here. And so then we have one last step, and that's solving for c. I'm going to go back to my equation I solved for c earlier. So we're going to go to c equals 3 times a. My a value here is 2/3. Therefore, c equals 2. And I then have my final answer of f of x equals 2 times 2/3 to the power of x. All right, we're now switching gears just a little bit and taking a look at a little bit of detail, dealing with some functions and some things we can do with functions. So, first of all, this equation up here, y equals x minus 5 squared plus 9. Is that a function? Yes, it is. Okay. Is it a one-to-one function?
No.
What?
So. Yeah, but I'm not really sure.
No. Now,
Yes.
let's get into some definitions because we're doing this problem because I want to make sure we remember the details and the definition here. Is it a function? Remember, in order for something to be a function, it has to pass the vertical line test. That's kind of that little trick we use to remember. Because there can be no more than one y for any given x. And so a vertical line there, notice, only hits the graph once. Here it hits once. Here it hits once, no matter where we go, it only hits once. So yes, it's a function. Now for it to be, yep, there's the bell, let's try that again. For it to be a one-to-one function, not only does it need to be a function and therefore pass the vertical line test, but it also has to pass the horizontal line test. And so you'll notice that in this case, it fails that, because if I draw a horizontal line across it, I hit it in more than one place at a time. And so, no, it is not a one-to-one function. One-to-one means that for any given x, there's one y. And for any given y, there's one x. There's never more. So it's basically kind of the idea of the function, the same idea of the function, except it goes both ways. So now that we know we have a function, we can go ahead and find our inverse of our function. So please find the inverse for this function. Now, one little note, a lot of people, when they start doing an inverse function, they'll actually start by turning it into y equals. But then what do? What is that critical first step in finding an inverse function? Yep, exactly. Swap the x and y. And so the very first thing you should do is turn it into x equals y minus 5 squared plus 9. Second step, solve it for y. Alright, so having practiced it with a nice old-fashioned quadratic, let's take a look at how all this stuff works with an exponential.
You sound so excited about it.
Alright, so in this case, we need to know, is it a function, and then is it a one-to-one function? Now, in terms of doing that, oftentimes the best way to know if something's a function is to look at the graph. You should actually be able to look at this equation and picture the graph, at least roughly what the shape is going to be. Because you know it's going to be an exponential function, and it is increasing, it is exponential growth. So you're looking at one of those. And you know that over here on the left-hand side, as we go left, that it's just trailing off and it's getting really close to an asymptote over there. Okay, so that alone, that picture alone should be enough to tell us, is it a function? Yes. And then, is it a one-to-one function? Yes, it is. Because function, vertical line test. One-to-one, also the horizontal line test. All right. Can you guess where we're going next? Please find the inverse, then, of this function. And so remember, our first step we want to do is we want to swap the x and y. And so I'm going to write my equation as x equals 10e to the y plus 4 minus the 3. And now it's just a matter of solving the equation for y. That's all, right?
Yep.
All right, so add 3 to both sides. So we got an x plus 3. Okay. Now I still need to get the e to the power of by itself, so that means getting rid of the 10. So I'm going to divide both sides by 10. And I'm still solving it for y. Y is stuck in the exponent. I now need to get it out of the exponent. So what do we do to get it out of the exponent? Yep. We got to turn it into a logarithm. And yes, in this case, our logarithm is a natural logarithm. Good. And so we end up with the natural log of x plus 3 over 10 equals the exponent. Because remember, log always equals the exponent. If you have trouble remembering what goes where when we go into log form, that's the phrase that I suggest you remember. Log always equals the exponent. Okay, well, I guess we only have one more step, right? Subtract 4 from both sides. Well, and maybe 2 more steps, because then rewrite it back again with our f of x notation. So I subtract the 4 from both sides. That gives me an inverse of f of x equals the natural log x plus 3 over 10 minus 4. All right, so we're going to go through all the work on this one here. But before I jump into it, this problem is actually a great illustration of kind of calculus as a whole in its own way, because the skills you're going to need here in calculus come from all sorts of different algebraic skills that you've learned up to this point. This problem actually brings in a lot of different skills, a lot of different techniques that used to be all from different units when you did them back in algebra and pre-calculus, stuff like that. But here, you're blending them all together to solve one problem. So let's see how we do that. First of all, to find an inverse, we know we switch x and y, so I'm going to start by doing that. I'm going to have x equals. So we swapped x and y. Now we have to figure out how I'm going to solve this equation for y. And in order to solve it for y, well, right now one of the things that makes that hard to do is the multiple logarithms. So you may recall that we've been practicing combining logarithms recently. It's useful here. And so this is going to become log base 2. Now the subtraction becomes division. So y squared minus 9 will be divided by y plus 3. Okay, so already we've made this simpler. Okay, now that I just have a single logarithm here, let's get rid of the logarithm. Turn it into an exponential. And so, 2 to the power of x, y squared minus 9 over y plus 3. This is where things start getting interesting and start getting tricky. Because one option, I suppose, would be get rid of the fraction by multiplying both sides by y plus 3. You could try it, but it's not going to work out very nicely for us. A much better method is just to reduce the fraction. Because you see you can cancel something from both the top and the bottom here, right? Well, if you can't, maybe if we rewrote the top slightly differently, we would see that yes, there is in fact something that we can do there. Notice that if we factor the top, we can cancel out the y plus 3, so actually 2 to the power of x only equals y minus 3. So if we add 3 to both sides, we end up with 2 to the power of x equals 3, 2 to the power of x plus 3 equals y or the inverse of f of x.